Hey guys, welcome back to the machine learning course for beginners by Uplatz. So in the previous lectures, we have completed regression, right? So we have completed simple linear regression and multiple linear regression. So today we will start off with the classification technique. So in the classification technique, the outcome will be discrete, okay? So for example, true, false, male, female, yes, no, all these are the examples of classification. So let's start with classification from this session. So we will start with KNN algorithm, okay? So the first classification technique is the KNN algorithm. So KNN stands for K nearest neighbor, all right? So it's a K nearest neighbor algorithm. So KNN can be used for both classification and regression, but it is more widely used in classification problems in the industry. So to evaluate any technique, we generally look at three important aspects, okay? The first one is the ease to interpret the output. The second one is the calculation time. The third one is the predictive power. All right. So KNN, KNN is one of the simplest machine learning algorithms based on supervised learning technique. KNN algorithm assumes the similarity between the new case and available cases and put the new case into a category that is most similar to the available categories. Okay. So it will assume the new point to which set of data points it is closer to, it belongs to that particular data set. It belongs to that particular data category, right? So we will see with an example later. KNN algorithm stores all the available data and classifies a new data point based on similarity. This means that when new data appears, then it can be easily classified into a well-suitable category by using KNN algorithm. KNN algorithm can be used for regression as well as classification, and mostly it is used for classification problems. And KNN is a non-parametric algorithm, which means it does not make any assumption on the underlying data. It is also called a lazy learner because it does not learn from the training set. Instead, it stores the data, and at the time of classification, it performs an action on the data set. So such algorithms are called as lazy learners, okay? Then KNN algorithm at the training phase just stores the data set, and when it gets new data, then it classifies that data into a category that is much similar to the new data. So for example, we have an image of a creature that looks similar to cat and dog, but we want to know either it is a cat or a dog. So for this identification, we can use KNN algorithm as it works on a similarity measure. Our KNN model will find the similar features of the new data set to the cats and dogs. And based on the most similar features, it will put it in either cat or dog category. So why do we need a KNN algorithm? So all those things we will start in this example. So the steps, how does the KNN work? The step one is to select the number k of the neighbors, okay? So we have to first select the value of k. The second step, calculate the Euclidean distance of k number of neighbors. Step 3, take the k nearest neighbors as per the calculated Euclidean distance. Step 4, among these k neighbors, count the number of data points in each category. Then the fifth step, assign the new data points to that category for which the number of the neighbors is maximum, then our model will be ready. So let's see an example for that. We'll explain you in simple terms by taking this example. So we have an example here on the screen. Suppose we have height, weight, and t-shirt size of some customers, and we need to predict the t-shirt size of a new customer by taking the height and weight as the input. Then the data including height and weight and t-shirt size information is shown in the table. So for this height and weight, the t-shirt size is given. So if the height is 158 and weight is 58, the size is medium, and 158 and 159, the size is medium. So all these are the medium size. Then if we want the other size, we will scroll down. Yes. So for 160 height and 64 weight, the size is large, and for few values, the t-shirt size is large. All right. So like this, you have to check the table. Okay. So these are the values for the t-shirt sizes that are medium and large. All right. So once the data is clear, once the data set is understood, the next step, calculate similarity based on distance function. Now, there are many distance functions, but Euclidean distance is the most commonly used distance measure, right? So we will use the Euclidean distance measure to find out the distance between the points. It is mainly used when data is continuous, and Manhattan distance is also very common for continuous variables. So the formula for the Euclidean distance measure is given on the screen. So d distance of x comma y, okay, is given by summation of I equals 1 to m xi minus yi whole square. Okay, so this is a formula we will be using. So here we have to find the distance between the new data point with all the other data points that are given in this table. Okay, you saw the table. So all those are the available data points. And now we will get a new data point. So let's see what is that new data point. The idea to use distance measure is to find the distance between new sample and training cases, and then find the k closest customers to new customer in terms of height and weight. So we will see what is the new data point. The new data point will have only height and weight as the input. So we have to check the t-shirt size for that particular customer. So the new customer named Monica has height 161 and weight 61 kg. So there is no output for this. We need to find the output as medium, large, or small. Okay. So now this is the new data point. The height is 161 and weight is 61 is the new data point. We have to find the distance between this data point with all the other available data points. So the Euclidean distance between the first observation and the new observation of, that is Monica, is as follows. So the first observation in our table was 158 height and 58 weight, correct? So that is how it is given. And the new data point has height 161 and weight 61. So I will calculate it as, so here x0 y0 is 161 and 158. and x1, y1 is 61 and 58. Okay, you can go back to the table and check the first row. The first row has height 158 and weight 58. So the distance between the new data point and the first data point is given by square root of 161 minus 158 whole square plus 61 minus 58 whole square. So what is 161 minus 158 is 3. Okay, 3 square is 9. Okay, then 61 minus 58 is also 3. So 3 square is 9. So it becomes 9 plus 9, 18, and square root of 18. Okay, so like this, we have to calculate it one by one. All right. So we have just given the distance between the new data point and the first data point. It was square root of 18. So the square root of 18 is given in this calculation table. It is 4.2. Okay, square root of 18 is 4.2. So like this, we have to find out the distance between the new data point and all the available data points. So for example, the second data point is 158 and 59. Okay, the height was 158 and weight was 59. So 158 minus 158 is 0 plus the second data point weight was 59 and the weight of Monica, that is a new data point, is 58. So 59 minus 58. So 1 square is 1 and square root of so there was a mistake here. So 158, 158. So 158 and 59, and the new data point was 161. Okay, 161 and 61. So now we can calculate it as 161 minus 158 is 3. Then 61 minus 59. So it is 4. 2 plus 2 whole square is 4. So it comes 9 plus 4 is 13. So square root of 13 is 3.6. Okay, like this, even the distance between the new data point and the third data point is 3.6. Distance between the new data point and the fourth data point is 2.2. Like this, we have to calculate distance between the new data point and all the data points and write it down like this. So we have to find the distance between the new data points and all the data points and write down the distance in the D column. Then we have to select the value of k. Now the k nearest neighbor, right? The k nearest neighbor, we have to select the value of k. So for example, we have taken k as 5. Okay, we have taken k as 5. So out of these data points, we have to find out the 5 nearest neighbors with the new data point. So select the 5 smallest distances. So the 5 smallest distances are 1.4. It is the most smallest distance from the new data point to the available data point. That is the fifth data point. Then what is the next smallest data point? 2. 2.0 is the second smallest data point. Then the third data points, we have two data points, two distances, 2.2 and 2.2, which are the third most nearest data points, and the fifth is 3.2. So here, if there are two distances of same value, you can count them as two separate distances. Okay, so for example, here there is a distance 2.2. You have to take 2.2 as two separate distances. Okay, so it becomes totally 5 distances. The first smallest distance is 1.4, the second smallest distance is 2, the third and fourth are 2.2 and 2.2, and fifth is 3.2. So these are the 5 nearest neighbors for the new data point. Okay, now, so once this is done, so here we have taken k as 5. Okay, so the algorithm searches for the 5 customers closest to Monica, that is most similar to Monica in terms of attributes, and see what categories those 5 customers were in. Okay, now you can see here, out of 5 nearest neighbors, 4 nearest neighbors belong to the medium size. Okay, out of 5 nearest neighbors, that is 2.2, 1.4, 2.2, 2.0, and 3.2. These are the 5 nearest neighbors. Out of these 5, 4 nearest neighbors belong to which category? The medium category. So it means we have to classify the new data point to the medium size category. Okay, so like this, the Monica's size, the t-shirt size, will be medium t-shirt size, because most of the neighbors, the majority of the neighbors are in the medium category. All right, so this is the solved example. So next, calculate KNN manually. Okay, so I'm showing you a graph. The t-shirt size is displayed in blue and orange color. Okay, you can see here, medium t-shirt size is in blue, whereas large t-shirt size in orange color. Now the new customer information is shown in yellow circle. The Monica's t-shirt size, the Monica's height and weight are 61 and 161. Okay, so it is shown in yellow circle. So now when you calculate, when you find out the 5 nearest neighbors, you can see 4 nearest neighbors are blue dots and 1 nearest neighbor is the orange dot. So it means Monica is much similar to the majority of the neighbors who are close to her. All right, so here, hence the t-shirt size of Monica can be classified as medium. All right, 4 blue highlighted data points and 1 orange data point are close to the yellow circle. So the prediction for the new case is blue highlighted data point, which is the medium t-shirt size. All right, so hope this is clear. So you can go through this table once again. If you have any doubts, you can mail us. So in the next example, we will see the implementation of this, using the packages. All right, so any doubts, you can mail us. Thank you.